Good morning, children. Listen, now 10th question from first exercise, 12, that is 12.1. Here the question is, let capital A be. That is, let capital A is equal to, that is the meaning. Here, capital A is a set. Capital A is a set which has the rational numbers except 1. So, the symbol known as except 1. That is, capital A is equal to Q minus 1. That is the meaning. Okay. Let capital A is a set which has the elements in the set of all rational numbers except 1. Determine star on A by x star y is equal to x plus y minus xy. So, which is the condition? This condition is very important. Here, star, say, A is a set and star is the operation. Okay? A is a set, star is the operation, where star is defined between the two elements means its answer is given by, listen, first element plus a second element minus first element into second element. That is a condition. So, this condition we want to use every time. That is very, very important. Okay? So, star is defined by some rule. The rule is, what is the rule means? That is, first element plus second element minus first element into second element. Okay. Is star binary on A? Is question. Listen, whether star is a binary operation on A? Question mark. Okay. If star is a binary operation on A, yes or no type question. Okay, because is. Okay, we want to say yes, star is a binary operation on A. And if it is no, no, star is not a binary operation on A. Like that you want to verify. Here, binary operation is nothing but closure action. Binary operation is nothing but closure action. Okay, so the first property I want to verify instead of binary operation means closure action. So first property I want to verify closure action true or not. Okay, that is the first. Next, if so, suppose closure action true means, suppose a star is a binary operation means, if so, examine the commutative action and associative properties satisfied by star on A. Okay, listen. If star is binary operation on A or star is closed on A, then I want to verify, I want to find commutative action and associative action. Okay, so there are, say, closure action first subdivision or binary property first action, first case, and say verify, that is finding commutative action second one, and third one is associative action. Listen, the first subdivision alone we have three parts. So closure action, commutative action, associative action. Okay, first part over. Come to second part. Listen, second part is separately given. Here again, let see the first two lines are same. Let A be Q minus 1. Determine star on A by x star y is equal to x plus y minus xy. Is star binary operation on A? If so, so the first two lines are same and one. Okay, the first two lines. The first two lines. And here also the first two lines. Okay, that is same and one. The first two lines are same. No difference. Differs only the properties only. Okay. If star is a binary operation on A, that is if star is closed on A, then I want to find, examine the existence of identity and the existence of inverse properties for the operation star on A. So already three parts, closure action, commutative action, associative action. Next I want to find identity action is fourth one and inverse action is fifth one. So I want to verify 5 properties. In examination point of view, together all the 5 topics can be asked in 5 mark question. Suppose first part alone 1 3 mark question and the second part alone 1 3 mark question. So that is examination point of view. Now, say, listen, we want to verify closure action, commutative action, associative action, and then identity action and inverse action. Suppose first part alone 1 3 mark question means only 3 topics. And suppose second part alone 1 3 mark question means here also 3 topics. Because first, second part alone 1 3 mark question means first you want to find a closure action. Closure action. Okay, closure action one answer and identity action second answer, inverse action third answer. So according to the question you want to answer. Suppose this both the topics in 5 mark question means it is enough to find a closure action one time. But a separate 3 mark question means for first topic 3 answers, for second topic 3 answers. Children listen. Now 10th question from first exercise. See the property one. Listen. So first property. First property is closure axiom. Closure axiom. Okay? Closure axiom. See, before closure axiom, let us select the elements. That is important. Listen. See, already sum is explained. Now solution. Listen carefully. Solution. Solution. Let capital A is equal to Q minus 1. Let capital A is equal to Q minus 1. That is which is given. Okay. So let capital A is equal to Q minus 1. Because in question paper available, so A is equal to Q slash 1. Which means A is a set of all rational numbers except 1. So instead of this symbol, this slash, we are using minus, that's all. Both are same. Okay, now again come to the question. Let A is equal to Q minus 1, which is given. It is meant that A is a set which has in the set of all rational numbers except 1. Okay, except 1, that is important. Now next step. Let x and y be rational numbers. Let x and y be the rational numbers. Be the rational numbers. Let x and y be the rational numbers and x is not equal to 1, comma, y is not equal to 1. So this step is very important. Again, let A is equal to Q minus 1, which is given in question paper. Let x and y be the rational numbers, because Q is rational numbers. We are selecting two elements such that x and y be the rational numbers, and say x is not equal to 1 and y is not equal to 1. That is important. Listen, conversely, x is not equal to 1, therefore x belongs to A. Y is not equal to 1, therefore y belongs to A. So that is a condition. Okay. Now, first, see, solution, which is the introduction. Now, subdivision 1. Subdivision 1 is closure axiom. Closure axiom. Okay? Closure axiom. Here, to prove closure axiom, it is a conditional question. So, initially, we want to write the condition for our convenience. Can you tell me what condition given in question paper? Yes, that is x star y is equal to x plus y minus xy, which is the condition given in question paper. And what is the condition? If star is defined between the two elements, then its answer is given by first element plus second element minus product of first element into second element. That is a condition. So this condition every time we have to use. That is very important. Okay, now come to closure axiom. Here x comma y comma xy are rational numbers. Therefore, clearly x star y is equal to x plus y minus xy is a rational number. Closure axiom. Clearly, listen, clearly x star y is equal to x plus y minus xy is a rational number. Is a rational number. Okay. Clearly, x star y is equal to x plus y minus xy is a rational number. Okay. But to prove x star y belongs to A, we have to prove that x star y is not equal to 1. So that is the idea. But to prove, x star y belongs to A. Because closure axiom means x star y belongs to A. So to prove closure axiom, it is enough to prove x star y belongs to A. Now, but to prove x star y belongs to A, we have to prove that x star y is not equal to 1. So a element which is not equal to 1, then only the element is belongs to A. So that is the condition. Okay. Yes. Clearly, x star y is equal to x plus y minus xy is a rational number. But to prove x star y belongs to A, we have to prove that x star y is not equal to 1. We have to prove that. we have to prove that x star y is not equal to 1. Okay, up to this correct. Now, see, okay, now, on the contrary, assume that, okay, now, on the contrary, listen carefully, on the contrary, assume that, x star y is equal to 1, that is not equal to 1, okay, yes. See, on the contrary, x star y equal to 1, because the element which is not equal to 1, then only the element is belongs to A. Now we are saying, on the contrary, assume that, contradiction answer you want to take. On the contrary, assume that x star y is equal to 1. Okay. On the contrary, assume that x star y is equal to 1. Then, now what is a condition? If star is defined between the two elements, its answer is given by? Yes, very good. Using this condition, every time I want to use condition. The condition is x plus y minus xy, which is equal to 1. That's all. Okay. Now x goes to right side. X goes to right side means minus x. So here, considering second term and the third term, y is common. So y into, what is remaining? Yes, 1 minus x bracket, which is equal to 1 minus x. X goes to right, minus x. And the next step, where say second and the third term taking out y, so y into 1 equal to y into minus x equal to minus xy, that's all. Okay, now next step, see, that is make y equal to something. Y is equal to 1 minus x goes to right, becomes divide. Okay, your answer is y is equal to 1 minus x divided by 1 minus x, that's all. Okay, can you tell me the answer? Yes, y is equal to 1. Okay, see, listen the condition. Since x is not equal to 1, that is a condition. Since x is not equal to 1, therefore the denominator 1 minus x is not equal to 0. Suppose not only denominator but also numerator in this question. Suppose 1 minus x is equal to 0 means you get 0 by 0, which is indeterminate form. Okay, the condition is x is not equal to 1, therefore 1 minus x is not equal to 0. That means x goes to right. So x not equal to 1, therefore 1 minus x is not equal to 0. Okay, we get the answer is y is equal to 1. Okay, see, initially we taken y is not equal to 1, but now we are getting answer y equal to 1. So this is impossible. Why? Because it is impossible. Yes, introduction is y is not equal to 1, but we are getting y equal to 1. So this is impossible because y is not equal to 1. This is impossible. This is impossible. This is impossible because y is not equal to 1. Because y is not equal to 1. Okay. Y equal to 1 is impossible because y is not equal to 1. Therefore, why we are getting impossible answer? Yes. Therefore, our assumption is wrong. Okay. Therefore, our assumption is wrong. Therefore, our assumption is wrong. See, what is assumption? X star y equal to 1 is the assumption. So, this assumption is wrong. Okay. See, on the contrary, assume that. We are assuming x star y is equal to 1. So, this assumption is wrong. Okay. Y equal to 1 is impossible because y is not equal to 1. Therefore, our assumption is wrong. Our assumption is wrong. Okay, therefore our assumption is wrong. Okay, see, our assumption is wrong means which is a correct assumption? Which is correct? Yes, which is correct means x star y is not equal to 1. Our assumption is wrong. Therefore, the correct assumption is x star y is not equal to 1. That's all. Listen, x is not equal to 1, therefore x belongs to A. Y is not equal to 1, therefore y belongs to A. Okay, now x star y is not equal to 1, therefore x star y belongs to A. Therefore, x star y. Therefore, x star y belongs to A. Okay, x star y belongs to A. Okay, x star y is belongs to A means therefore closure axiom is true. That is, star is closed. That is, star is a binary operation on A. Therefore, star is a binary operation. Star is a binary operation. Binary operation. Therefore, star is a binary operation on A. Okay, that is, we can write in three ways. That is, star is a binary operation on A, or star is closed on A, or closure axiom is true. All the three sentences are correct. Okay, so the first subdivision, closure axiom is completed. First subdivision, closure axiom is completed. Okay, now we are moving a next page. That is important. Okay, listen the next page. That is first subdivision is closure axiom is completed. Now listen, subdivision 2. Subdivision 2 is commutative axiom. Okay, commutative axiom. Commutative axiom. Commutative axiom. See, we know that, can you tell me the definition of commutative? Yes, A star B equal to B star A. But here we are considering the elements x and y. Therefore, we want to prove x star y is equal to y star x. Okay? Now listen, x star y is equal to, now what is the condition for star? Yes, the condition for star is first element plus second element minus first element into second element. Okay? That is, listen, first element plus second element minus first element into second element, which is a condition. Yes. Now, which is equal to, say, x plus y. Say, now we want to prove commutative axiom. For commutative axiom, A star B equal to B star A. So here, listen carefully. Here x and y are rational numbers. The relation is addition. So, addition is commutative in the set of all rational numbers. Okay. Listen. Addition is commutative in the set of all rational numbers. That is, x plus y equal to y plus x. X plus y equal to y plus x. So, x plus y is equal to y plus x minus, here x into y. X into y is the multiplication. So, multiplication is commutative in the set of all rational numbers. Therefore, x into y equal to y into x. Commutative. So, x into y is equal to y into x. That is commutative. Okay. Now, which is equal to, listen, x star y is equal to x plus y minus xy. That is conversely, here first element x, so that is why left hand side first element x. Second element y, so left hand side is second element y. Okay, similarly, first element x, first element x. Second element y, second element y. Now, can you tell me conversely? Now, first element y. First element y, therefore here first element y star, second element x. Therefore, x, that's all. Again, first element y, second element x, second element x, that's all. So, y star x. Initially we taken x star y, finally we proved y star x. Okay, therefore, x star y is equal to y star x. A star b equal to b star a, commutative. Okay, so x star y is equal to y star x. Therefore, star is commutative on A, or commutative axiom is true. Okay, commutative axiom is true, or star is commutative on A. Therefore, star is commutative. Star is commutative on A. Star is commutative on A. Therefore, commutative axiom is true. Okay. Therefore, commutative axiom is true. Also correct. Therefore, commutative axiom. Therefore, commutative axiom is true. Therefore, commutative axiom is true. And before also, star is a binary operation on A. Therefore, closure axiom is true. Therefore, that is closure axiom is true. Therefore, closure axiom is true. Okay. Now, two subdivisions completed. Children listen. Say first subdivision, closure axiom is true. Second subdivision, commutative axiom is true. Okay, can you tell me what is the third subdivision? Yes, the third subdivision is associative axiom. Okay, listen, subdivision 3. Subdivision 3, associative axiom. Associative axiom or associative property, both are same. Okay, associative axiom. See, can you tell me definition of associative? Yes, A star B star C equal to A star B star C. Okay. Now let us take LHS of the associative. The LHS of the associative is given by A star B star C equal to. Okay. Now see, instead of ABC, the given question is XYZ. Okay, XY. So that is why alphabetic order XYZ. Why not ABC also correct? XYZ also correct. Because the question given X star Y. So let us use XYZ. So that for our convenience. So that is important. Okay. I am taking LHS of the question. Okay. That is LHS of the associative. So associative axiom is given by X star, say X star Y star Z is equal to, that's all. Okay. See, X star Y star Z is equal to X star Y star Z. I want to prove. Now, taking that is LHS of the associative is equation number 1. Then RHS of the associative means change the bracket RHS of the associative equation number 2. From 1 and 2 it is clear that the RHS right hand sets are equal, therefore the left hand sets are equal. Like that I want to prove. So that is why X star Y star Z is equal to. Okay. First we complete the bracket answer. That is important. Bracket answer. Here X star fixed. Listen carefully. X star. Okay. X star fixed. Complete the bracket. What is the bracket answer? Yes. Because if star is defined between the two elements, then its image, then its answer is given by first element. Listen. First element plus second element minus first element into second element is a condition. Is every time we want to use the condition. Okay. See, the condition is X star Y is equal to X plus Y minus XY. Every time I want to use this condition. Okay. Keep the condition in the mind. That is very important. Again, X star fixed and complete the bracket answer. So Y star is equal to, say, first element plus second element minus first element into second element. Okay? Now here after yourself. Yes, here star before one element and the star after fully considered as one element. This fully considered as one element. Now first element star second element. Okay, what is the rule? Yes, the rule is given by first element plus second element. Okay, first element plus the second element. Okay, minus first element into second element. That's all. Listen to the technique. If the star is defined between the two elements, then its answer is given by first element plus the second element minus first element into the second element. That's all. Okay. What is bracket? Yes, where the bracket is equal to y plus z minus yz. Okay, what is this bracket? Y plus z minus yz. That's all. Now just your algebraic simplification. Okay, which is equal to, start your answer. Here x plus into anything the same. So x plus y plus z minus yz over. Now minus and x going to multiply inside the bracket. Okay, minus x going to multiply inside the bracket. Can you tell me your answer? Yes, that is minus x into y minus xy. Okay, next. Minus x into z, minus into plus minus. Minus x into z, minus xz or minus zx by cyclic order. Cyclic order means xyz, x to y, y to z, z to x for our convenience. So therefore, here minus x into z minus xz by cyclic order minus zx. That is z to x. Also correct. Next one. Say minus into minus plus x into yz plus xyz. So up to this answer ready. Now listen, x plus y plus z minus, so listen, x plus y plus z minus xy minus yz minus zx plus xyz. Now I want to write in order. So for my convenience, which is equal to x plus y plus z is in order. Next I need x to y, y to z, z to x, which means xy, yz, zx. Like that, like this cyclic order I want to write. Okay, first xy. Yes, xy is available minus xy. Next yz. Yes, yz is available minus yz. Next zx. Yes, zx is available minus zx plus xyz. let it be which is equals number 1 and whose left hand side is x star y star z. Okay. Now we are taking LHS of the associative. Let it be equals number 1. Now I want to consider RHS of the associative. RHS is nothing but changing the bracket. Okay. Now start here. Yes, very good. Here last two are in the bracket. Now first two are in the bracket. That is x star y star z is equal to. Okay. Now here after yourself. Yes. First complete the bracket answer. The bracket is, what is the condition? Yes. The bracket answer is first element plus second element minus first element into second element. Okay. The bracket answer over. X star y is equal to x plus y minus xy is a condition. Star is at fixed. Star is at fixed. Okay. Now here after yourself, which is equal to. Yes. Here the first bracket fully considered as the first element and the star is the second element. The technique is, listen, star before one element and star after one element. First element, second element. What is the condition? Yes, if the star is defined between the two elements, then its answer is given by first element plus the second element minus first element into second element. Okay, start your answer. So which is equal to first, listen the technique. Before that, we can write the techniques. Listen, which is equal to first element plus the second element. First element plus the second element minus first element into second element. That's all. Okay, what is bracket? Where bracket is equal to x plus y minus xy. Next, minus first element into second element. What is the first element? Yes, the bracket is the first element. That is x plus y minus xy. Okay, now which is equal to? Now just algebraic product. Algebraic product means here this moon bracket no need. You simply write. That is x plus y minus xy over plus z. Right as it is. Now this minus and z going to multiply inside the bracket. Okay, start your answer. Yes, minus x into z. Minus x into z equal to minus zx for our convenience. Minus zx. Next, minus y into z. Yes, minus yz. Minus into minus plus xyz. So plus xyz. Okay. Now next step, I want to write in order. Okay, order. What is the order? X plus y plus z. First, x plus y plus z. Next, x to y. Yes, xy minus xy. Next, y to z. Yes, yz minus yz. Next, z to x. Yes, z to x minus zx. We taken all the three negative terms. Okay. Next, the last term is plus xyz. Now count it, the number of terms. 1, 2, 3, 4, 5, 6, 7. Yes, here 1, 2, 3, 4, 5, 6, 7. Okay, let it be which is equals number 2. Whose left hand side is given by, whose left hand side is x star y star z. Okay. Now, first equation LHS of the associative and the second equation RHS of the associative. Now, by individual inspection, I want to verify whether the RHS are equal or not. Okay, count it. Yes, x plus y plus z minus xy minus yz minus zx plus xyz. So RHS are equal, therefore LHS are equal. Okay, from 1 and 2 it is clear that. From 1 and 2. From 1 and 2 it is clear that RHS are equal, therefore LHS are equal. Therefore, listen, therefore x star y star z is equal to x star y star z equal to, now change the bracket, that is which is equal to x star y star z. Okay, therefore star is associative on A. Therefore star is associative. Therefore star is associative on A. Therefore star is associative on A. Therefore star is associative on A, which means associative axiom is true. Therefore associative axiom is true. Therefore associative axiom is true. Okay. And also x star y star z is equal to x star y star z, which is true for every, yes, it is true for every x comma y comma z belongs to A. That's all. So associative axiom is completed. Listen, for first part 1, 2, 3, 4 lines. For second part, 1, 2, 3, 4 lines. Okay, that is very important. Part 4. Listen carefully. Part 4 is given by identity axiom. Identity axiom or identity property or existence of identity. All are same, no problem. Identity axiom, identity property or existence of identity. Both are correct. See, all the three are correct. Okay, Bob. Now, see here, there is this question is conditional question. See, that is x star y is equal to x plus y minus xy. So, for this condition, I want to find the identity element. Okay, so let E be the identity element of A for our convenience. Let E be the, listen, let E be the identity. Let E be the identity of A. Let E be the identity element of A. Okay, let E be the identity element of A. Now, by the definition of identity, okay, now by the definition of identity, or now by the definition of E, also correct. By the definition of E, by the definition of E, where E means identity. So this sentence one can write like this also. By the definition of identity, or by the definition of E. Okay, can you tell me what is the definition of identity? Yes, by the definition of identity, A star E is equal to E star A is equal to A. Here identity topic gives the same element answer. Okay, same element answer. A star E is equal to E star A is equal to A. But here we are selecting X, Y, Z, you know. So that is why X. Now listen, by the definition of E, X star E is equal to X star E is equal to E star X is equal to X. And we are not writing the second one. X star E equal to E star X is equal to X. We are considering first and last. Okay, first and last means X star E is equal to X. Here remember, here X is any one element and E is the identity element. Identity topic gives the same element answer. So X is the answer, not identity answer. Identity topic gives the any one element. Here X is any one element and E is the identity. Therefore, we are getting that any one element will be the answer. Okay, now first line over. Now second line is by the definition of star. By the definition of star. Okay. By the definition of star means the given condition. Okay. Now by the definition of star, take the same LHS. The same LHS is X star E is equal to. Okay. X star E is equal to, by the definition of star means first element plus second element minus first element into second element. X into E. That's all. Okay, let it be which is equation number 2 and it is equation number 1, equation number 2 for our convenience. Again, very simple. Let E be the identity element of A. By the definition of identity, X star E equal to X, first equation. By the definition of star, X star E is equal to first element plus second element minus first element into second element. Okay, now from 1 and 2. From 1 and 2. Yourself? Yes, here X star E. So LHS are equal. Therefore RHS are equal. So we can do 2 equal to 1 for my convenience. Second, yes, 2 equal to 1. That means what is the second? X plus E minus XE is equal to X. That's all. Okay, here identity is the topic. I want to find the identity E. So that is why this, the second term and the third term fixed. This X goes to right, becomes minus X. Now listen, where in second and the third term E is common. Okay, E common means what is remaining? 1. E into 1 equal to E. Okay, next step. Yourself? Yes, minus X. Which is equal to X minus X. Because already X goes to right minus X. Now yourself. Yes, minus X, say minus X plus X cancel, which is 0. And also, now, here, E is equal to, listen, E equal to 0 by 1 minus X. E is equal to 0 by 1 minus X. Okay. Now remember the condition. Say the condition is X is not equal to 1. X is not equal to 1. X is not equal to 1 and this X goes to right side means X is not equal to 1. Therefore, 1 minus X is not equal to 0. 1 minus X is not equal to 0. 1 minus X is not equal to 0. That is important. Okay, suppose 1 minus x equal to 0 means 0 by 0 is indeterminate form. So that is why. Okay, now 1 minus x is not equal to 0, therefore 0 by any number equal to 0. That is E is equal to 0. Okay, E equal to 0 belongs to A. Okay, E equal to 0. Yes, 0 belongs to A. But 1 is not belongs to A. 1 is not belongs to A, but 0 is belongs to A. Therefore, the identity element is E equal to 0 belongs to A. Therefore, listen carefully, therefore the identity element is E equal to 0, which is belongs to A. Therefore, identity axiom is true. Therefore, identity axiom is true. Identity axiom. Therefore, identity axiom is true. Okay, which is subdivision 4 is completed. Now I want to move next page. That is very important. Okay. See, also listen carefully. I want to move next page. The next page. What is the topic, please? Yes, fifth topic. Okay. Can tell me the fifth topic? Yes, that is inverse axiom. Inverse axiom. Okay. Inverse axiom is the topic. Inverse axiom. Okay. Now, see, inverse topic gives identity answer. That is very important. Identity E. Okay. Now listen. Let here we are taking XY set. So that is why let X inverse be the inverse of X. Okay. Let X inverse be the inverse of X, which is belongs to A. Okay. Let X inverse be the inverse of X, that X is belongs to A. Okay. Now as usual, see, from the before idea, by the definition of identity, by the definition of star. Likewise, now also by the definition of inverse and by the definition of star. That's all. Now by the definition of inverse, by the definition of inverse, otherwise by the definition of X inverse, both are correct, because X inverse is the inverse of X. We have taken X inverse is the inverse element of X. That is why by the definition of X inverse or by the definition of inverse. Okay, can you tell me definition of inverse? Yes, A star A inverse is equal to A inverse star A is equal to E. But here we are using X. So by the definition of X inverse, X star X inverse is equal to X inverse star X is equal to E. And we are forgetting the center. X star X inverse is equal to X inverse star X is equal to E. We are considering first and last. Okay. Now next step. Let it be which is first equation. Okay. Now by the definition of star, by the definition of star. Okay. By the definition of star, can you tell me what is the definition of star? Yes. By the see, take the same LHS. That is important. I want to take same LHS, don't forget. And before also, I want to take same LHS. We are taking same LHS. And here also same LHS. That is same LHS is X star X inverse is equal to. Okay. What is the definition of star? Yes, very good. See, first element plus yourself. Yes. Second element X inverse minus, yes, X into X inverse. That's all. Let it be second equation. Okay. Now, listen. X star X inverse, X star X inverse. LHS are equal, therefore RHS are equal. And also one more idea. See here, what is E? Yes, can you tell me what is E? Yes, E equal to 0, because before answer. Before answer is E is equal to 0. Yes. See, X star X inverse is equal to E. E is equal to 0 from identity topic. Okay, E answer we want to write. Now LHS are equal, therefore RHS are equal. From 1 and 2. From 1 and 2, RHS are equal. RHS are equal means, let us use 2 equal to 1. That is, 2 is equal to 1 for my convenience. Okay, what is second equation? Yes, X plus X inverse minus X inverse, which is equal to 0. Okay, because E equal to 0. Okay, E equal to 0. Now, inverse is the topic. So, X inverse left side, others right side. Okay, now X inverse common. x inverse into, what is remaining? Yes, 1 minus x, which is equal to, see, already 0 minus x, that is minus x. 0 minus x equal to minus x. Now remember, x inverse is equal to, bracket goes to right, becomes divided. So x inverse is equal to minus x by 1 minus x. Okay, x inverse is equal to minus x by 1 minus x. Now, small adjustment, the numerator, see, the numerator minus belongs to both the denominator. Listen the technique, minus into minus plus x, minus into 1 minus 1. So, this minus going to multiply in denominator, we get, otherwise one can do like this also. Multiply by minus 1 and say multiply by minus 1 and divide by, say multiply by minus 1 both the numerator and the denominator. The value will not change. Okay. So say downwards, want to listen carefully, the place is sufficient or not. Okay. Yes, the place is sufficient in downwards. So I want to do minus into minus. Otherwise one can do like this also. So minus 1 is multiplied with the numerator and the denominator also multiplied by minus 1. Okay, denominator also multiplied by minus 1. See, numerator and the denominator multiplied by minus 1, the value will not change. Otherwise, the easy technique, minus into minus plus x, the numerator minus comes in denominator, that's all. Okay, then tell me x inverse equal to x divided by, okay, x divided by minus into minus plus x minus 1, which is belongs to A. Okay, x inverse is equal to x by x minus 1 is belongs to A. Therefore, inverse of x is x inverse is equal to x by x minus 1. Listen, therefore inverse of x is x inverse is equal to x by x minus 1. Okay, inverse of x is x inverse is equal to x by x minus 1, which is belongs to A. Therefore, inverse axiom is true. Inverse axiom is true. Therefore, inverse axiom is true. Okay. So, hence the answer.